In this video, we're going to learn about the concept of oxidation numbers. Oxidation numbers are a system of numbers that we assign to elements in order to track if a redox reaction is happening. Keep in mind that oxidation numbers, they're not the actual charge of the atom necessarily, but they're numbers that we assign based on rules just to let us know if a reaction is considered redox or not. And remember that for a reaction to be considered redox, there has to be a transfer of electrons. And the way to keep track of that is by using this oxidation number system. So to assign oxidation numbers, you follow a list of rules. And as long as you follow those rules, it should be fairly straightforward to assign oxidation numbers to a variety of different substances. The sum rules are the most important ones. The zero sum rule essentially means suppose you have a compound like CO2 with no overall charge, meaning zero. The oxidation numbers of each element must add up to zero. So they might each have different oxidation numbers, but they must add up to zero. But if you have a substance with a charge, like let's say NO3 minus, like -1, then what that means is that when you add the oxidation numbers of each element together, they must come up to the overall charge of the substance, which is -1 in this case. So if there's no charge, make sure they add up to zero. If there is a charge, make sure they add up to that charge. So how do you assign these numbers? Well, we follow a list of rules here. Any atom that's considered an element, like a monoatomic element or a molecular element, for example, like Na is atomic element, O2, O3, those are all molecular elements, Hg is atomic, those would have an oxidation number of 0. Monoatomic ions, in other words, just ions, even if they're in compounds, they will usually have the oxidation number that matches their charge in the periodic table. So for example, Na is +1, chlorine is -1. Now, a few other additional rules that you have to pay attention to. Fluorine is always going to be -1. So for example, in this compound over here, fluorine will be -1 as an oxidation number. And since this compound has an overall charge of 0, then that means that a hydrogen must be +1. Over here in PF3, fluorine is -1. Now, since there's 3 fluorines, that means we have -3 total. Now, each fluorine individually is -1. That's the oxidation number. But there's 3 fluorines, so it's -3. And since the overall charge is 0, that makes phosphorus +3. But the point is that we use the rule of fluorine being -1 in order to find out what phosphorus was. Oxygen is usually -2 in a compound. So for example, here we have H2O. Oxygen is -2, making water +1. Since there's 2 hydrogens, it's hydrogen +1. Since there's 2 hydrogens, it's +2 minus 2 is 0. There are exceptions to this though. So oxygen does have an oxidation state of -2, but if you have it in peroxide compounds like hydrogen peroxide, it's actually -1 instead. So this is -1, there's 2, it's -2 total. Therefore, it's a +1 over here, that's +2 total. So +2 and -2 make 0. Peroxides, remember, they're substances that have an extra oxygen than they should. So for example, K2O, this is the regular oxide, because if you do the crisscross with the charges in the periodic table, you get K2O. But if you have K2O2, this is an additional oxygen. The per oxide, the per part means one more extra oxygen. So in here we'd have a oxidation number of -2 and +1 for this. But over here we'd have -1 and +1 for this because it's a peroxide. Lastly, hydrogen always needs to be +1 in most compounds unless it's in what's called a metal hydride. A metal hydride is simply where you have hydrogen combined with a metal. So normally hydrogen is +1, but when it's with a metal hydride, hydrogen is considered -1 instead. So in this case here, the hydrogen is -1. There's 2 of them, so that's -2. Calcium is +2, since that's the charge in the periodic table, but also is what gives it 0. So here, for example, oxygen is -2, and then hydrogen is +1. Unless you have a metal hydride, then it's -1. So these are the general rules you have to pay attention to and follow when you're trying to assign oxidation numbers. We're going to do some examples together, and really the best way to memorize these rules is by doing practice. So let's start with CO2. One of the first rules that comes to mind here is that oxygen has to have a oxidation number of -2. Now, since there's two oxygens, what this would mean is that each oxygen is -2, so overall we have -4 here. Since this has to be 0 because there's no charge, that makes carbon +4. So carbon is +4. Remember that the oxidation number is for the individual atom, but when you're trying to find the overall, you have to take into consideration the subscripts and how many atoms there are in that compound. You can try NO3 on your own, pause the video, then check your work. So here we have, once again, NO3 minus. Oxygen should be -2 because that is the rule. So since it's -2 and there's 3 of them, that means you essentially have -6. Now nitrogen is going to be whatever allows us to reach this total here, which is -1. So that means nitrogen has to be +5 because -6 plus 5 is -1. Try the next one on your own and then check your work. Pause the video, try it, check. So here we have Na2S2O3. We have -2 for oxygen, right? Because that's what it should be, -2. Sodium is a ion in the periodic table, so its charge in the periodic table matches its oxidation number, +1. Sulfur is what we have left to try out. So we have sodium being +1. And the way to look at it is you have -2, so 3 oxygens and -2, that's -6. And here you have 2 and +1, that's +2. So overall, this makes -4. For this overall oxidation number charge to be 0, this must be +4. So sulfur, with 2 of them together, make +4. But since there's 2 sulfurs, you have to do +4 divided by 2, that's +2. So those are the oxidation states for each element in that compound. Next, you'll try the U-try problems here. So again, try it out yourself and then unpause the video and check your work. So here we have H2PO4 minus. Again, H should be +1. O should be -2 because it's not a peroxide. Now the thing is, since it's -2, that means there's -8 because there's 4 of them, and here there's +2 because there's 2 of them. Together that makes -6. Now you want the overall charge to be 1 minus, because that's what we have there. So -6 plus 5 is what would make 1 minus. So phosphorus is +5. Let's try this one out over here. So H once again needs to be +1. S we're not sure of yet because we're going to write down to 1 we know for sure. Oxygen is -2. So we have -2, +1. This means we have -8, and this means we have +2 here. Together that makes -6. So that means sulfur must be +6. So that's how you find oxidation numbers for elements in compounds and elements not in compounds. Those are the rules you have to follow. To practice, you can try the practice problems over here. The more practice you do, the better off you'll be. And it's important to check your work every time to make sure you're on the right path. Once again, understand the oxidation numbers are not necessarily the actual charge of the element. They're simply assigned based on a list of rules, and they're going to be used in order to help us figure out if we have redox reactions or not. And that'll be the next video.